Tonight is May the 27th, 2019, Veterans Day. And I thought about opening this video up with showing my uncle's World War II uniform. He was drafted in 1941 and served in Germany over there as a infantry. One of these guys that you see on the movies running through the fields and all that stuff, carrying that M1 rifle, and he's passed away now. He was born in 1923, but I just couldn't really bring myself to do it. But my many thanks to all the veterans of all the wars that have kept this great nation safe. With that said, let me show you some things that you might find interesting. Okay, this is an amplifier I've shown a number of times. It's a channel out of an MA230 McIntosh. It's rated at 30 watts. It'll do like 45 watts. But I think what I want to do tonight and see for myself and is use, these are Svetlana, some older ones, and they're actually quite good. These are EL34s, but here's the real prize right here. Let me show you this to you ladies and gentlemen out there. I have four, had these for quite some time. Four absolutely beautiful Mullard EL34 6CA7s made in Great Britain. They're all absolutely beautiful. They have all the logo on them. I believe they were made around 1959, and they perform very, very well. So what we're going to do is something simple, kind of like I did the other day on the in comparing tubes. I want to compare the new ones, these Russian tubes, which I think perform very well. See, there's another one. It's got a little bit of the artwork off of it. And then we're going to compare it to these brand new Genelex KT66s. We'll set them up exactly the same way, drive them with the same level. Well, no, we'll have to actually change. We may have to actually change the level a little bit to get to the same power level. We're going to measure them all at 30 watts, and then we'll, scan them once from 20 to 20 kilohertz at the rated power, and then we'll also see their maximum power at 1 kilohertz. So you can see there's another one. Now these perform very well. I've had them for a number of years. I don't know why I don't use them. I guess because they're so special. Sometimes things are too special and we don't use them. And then these are the two brand new Genelex KT66s. So I'll put them in there. I'll adjust the bias to the same point each time, and let's see how they do. It does exceptionally well at its rated power. It's just pretty much unbelievable. It's hard to believe they only rated it at 30 watts. I've got the little LED watt meter on there, which we don't really care about. I'm just going to be using this one. That's an easy one to see, because it just works really nice when I made that video on the other night. Okay, enough talking. Let's run it at 30 watts and get started here. This guy right here, run that up to 30. Hope you can see that. The digital one measures 29.63, so that's perfectly good. And there it is, right there. 0.05% at 2 kilohertz. That is pretty amazing. 0.05%, 1 kilohertz. Or 2 kilohertz, sorry. I do that so that I don't have to do a lot of twisting. Let's go to 20 hertz. Let's just get with the program here. There's 20 hertz. There's its power. 0.28. 20 hertz, 0.28%. And then we'll do it at 20 kilohertz. You can see the power dropped ever so slightly. We're not going to worry about that right now. There's our 20 kilohertz. 0.277%. 20 kilohertz. 0.277%. That is exceptionally good Okay, now let's scan it once, and let's see how that runs. Close all these others. I'll have to set it up. Actually, it'll take me a second to set it up. Okay, we're set up for 30 watts. 31.27 to be exact. Our other meter says a very similar thing. Now let's get over here and zoom right in on this guy and see how this thing turns out. It's going to turn out quite good, as you'll see. THD starts out at about 0.35, and then drops down to 0.1. Actually, it says it's 0.07. You can see that in the camera right there. Below 0.1%. Just unbelievably flat. It's just, I don't know how anything could do much better. And then it rises to about the same amount out at the other end, around 20 kilohertz. And then I'll let it cool down nicely, because I don't like to pull out tubes while they're hot. And there it is, 20 kilohertz, and it's out there. The last number was 0.32. Pretty much the same kind of numbers we got a while ago. So there you go. That's what the Svetlana ones do, which are quite nice. You can look this up if you want to, MA230, McIntosh MA230, and you'll get the schematic for this thing. You can balance, you can adjust the bias on each tube separately, and then you can adjust the dynamic balance of the driver to the tubes. Okay, let's turn it off, let it cool down, and let's try the ethereal Mullards. Okay, now we have a couple of the vintage Mullards in there. I just plugged them in, let them warm up, and then tested them without balancing the and setting the cathode currents at exactly 50 milliamps, which is what I set all of them at. And they weren't balanced. And I balanced the driver stage too. I'll show you. You're going to see it run live here. But this is the performance of it before I balanced them, before I set the, let me turn this light off. This is how they performed before I adjusted the cathode currents to exactly 50 milliamps each and balanced the driver. So let's see how it does on trace 2. We'll just see how just really important it is to balance these things. There it is. Look at that blue line. It started out about the same place. It looks like it's doing the same thing as the Svetlana's, but it definitely accentuates when you swap tubes. No matter how good they're supposed to be, or how old or how new, if you don't have a way of balancing the cathode currents and balancing the driver to it, probably balancing the driver is not as important. But once it's balanced right, it probably stays balanced actually for all of them, for whatever you put in there, because you're not drawing in a grid current. But it made a dramatic difference in the performance here. Look at that. That is better. It actually is better. Okay, now let me see here. See, here's the other one. This is the Svetlana's right here. I can run as many versions, not versions, but copies as I want. Svetlana's were right here. So it ended up at 0.3. It started out at like 0.35 and ended up at 0.3. Okay. This one started out at 0.35 and ended up at about 0.25. So it's actually a little bit better on the high end. This is balanced. This is unbalanced. This is just plug them in and turn it on. How about that, ladies and gentlemen? Okay, it's kind of dark in here now. Let me move back away, and I will we'll do the last ones. Turn the lights back on here for just a second. Let me see what I'm doing. Okay, I'm going to turn these guys off. Let them cool down for a little while. And then we'll put these KT66s in there. I think I'll do the same thing on the third version of it. I'll just plug them in to see how they perform, and then do the balance and run them again. Okay, now they're in there. These brand new Gold Lion custom tube KT66, beautiful tubes. I have not balanced them, so I'll let you watch this one run too. I've got it all set up to minimize the amount of time it takes here. Let's see how they do without adjustment. Well, not bad, huh? It's performing quite well down here at the Harrow 0.35. But the overall performance is actually, they're not dropping as low. The others were dropping down to, if I remember, 0.07. They were dropping down below 0.1. This one's 0.2. So in that sense, they're not doing near as good. But as soon as this gets through, I will carefully balance them and see if that makes any difference on these. There it is right there. I mean, that's still textbook perfect. 0.46 at the end. A little higher than the others. These are the KT66s, so let's balance them and see how they turn out. Okay, so you'll know exactly what I'm doing. That was actually a bad idea what I just did, because see, I'm measuring the voltage across some precision 1 ohm resistors, and there's my 50 milliamps right there. See, this is on the 0.6 volt scale, so it's 0.5, and when I put these probes in here, this meter went ping, and it was pegged well past 60 milliamps. I don't think I hurt the tubes, but I tell you, there's a lesson to be learned there. I should know better. You need to monitor your cathode current when you plug in new tubes. If you've got adjustments on them and you really care about it, you need to monitor your cathode current as from the beginning. I don't know what it was, but it was pegged hard, so it was probably 75 or 80 milliamps per tube. It was, I'm sure, exceeding the plate dissipation of the tubes. All right. Well, I'm glad I didn't destroy my tubes. I've been stupid and didn't done it before. Let's see what happens now that they're beautifully balanced. Yeah, those were running hot, hot, hot. Just outrageously hot. Didn't seem to change the low end very much, did it? You know, I'm always saying, and I've said this so many times, I continue to say it, that the hotter you run them, the better they perform, up to the point of destruction. Well, it almost proves that, but I guess I went a little bit past anything of common sense there. I wish I'd have known. I wish I'd known exactly what they were saying. I'm going to say they were, 70 or 80 milliamps per tube at least. Well, that's it. It changed it a little bit, but the EL34s actually performed a bit better. The last THC was 0.31. I can't remember all this in my head, but I know the EL34s perform a good bit better. Well, let's see what the maximum power is now. Let's just do that. We've got all this up here. There's our KT66s, unbalanced and balanced. We can look at all of them again. There's our EL34s, unbalanced and balanced. Boy, that made a lot of difference, didn't it? These are our old 1959 Mullards. There's our Svetlana ones. They're balanced right there very nicely. I don't have them unbalanced, but they perform exceedingly well below 0.1%. Actually, I don't see any significant difference between them and the Mullards. The Mullards are actually a teeny bit better at the high end up here. 0.25 versus about 0.3. Well, that's pretty insignificant, isn't it? The EL34s outperformed the KT66s in this amplifier, but let's just see what absolute maximum power is at some percent. Let's say, you know, 1%, whatever. Let me set that up here. We'll have to actually go back through the tubes again, but we'll start with these. Okay, I'm setting THD to as close to 1% as I can, and there it is. You can actually see a tiny bit of flat topping right there. Looks a little the symmetry isn't perfect. I see a little bit more of a flat top there than I do on the bottom, and it's we call that 42 watts. 42 watts at 1%. At 1 kilohertz. That's, I guess that's where the rubber meets the road brutal test. Absolute maximum power at 1%. I don't see any sense in running it up to 5 or 6% or whatever. Okay, 42 watts at 1% for the KT66s. Now let's go backwards. Let's put the Mullards in there, the vintage Mullards. Okay, now we got the vintage Mullards back in there. I did go through and set the bias again for 50 milliamps of cathode current, and I'm telling you that the bias difference between the KT66s, which is going to be very similar to a 6L6 or a 5881, and these EL34s is dramatically different. When I put these in, the cathode current was down around 10 milliamps. Remember, this is all making sense now. The bias voltage on these have to be actually quite a bit lower than it does on the KT66s. So you pull out your KT66s and you put in your EL34s, and you're going to be running them really, really cold with the same negative voltage on the grid. But if you pull out your EL34s and plug in 6L6s, you're going to be in trouble. It is not going to work unless you have got quite a good range. Now, as long as I've had this amplifier, I'm driving it now. Yeah, see, there's the 50 milliamps right there. That's a little bit more because I'm driving it pretty hot. That's one channel. That's the other channel. But the bias was very, very negative. It was much too negative for these, which makes this one much too positive for these. So don't pull out your EL34s and plug in 6L6s blindly, rolling tubes, so to speak. You're probably going to regret that. Okay, enough of that. Let's get back to there's its THD. Let's run this up to 1%. Let's see what we get. Okay, why is it bouncing around so darn much? I got probably loose connections. Sorry for the fumbling, but when you're using 40-year-old equipment, sometimes you have to pamper it a little bit. You've seen that happen before. Okay, there's 7%. We don't want that much. We want it back down there as close to 1 as we can get it. 1.1, 0.7. There it is, 0.9. 46.8 watts. Call that 1%. 46.8 watts. The other one did 42. Wow. 46.8 at 1%. So the EL34s are winning hands down, aren't they? I actually know that. I expected that. I mean, that's not a whole lot of power, about 5 watts more, but they do win the race here in THD. There's our little LED meter blinking away. I'm not even going to try to interpret that. Look where this thing is sitting. See, there it is, just under 50 watts. It looks like this one's measuring 48 watts, and this one's measuring 47. So I'm still really pleased with this guy right here. Okay, last one now. Let's see what the maximum of these guys will do. I'm assuming I won't have to adjust the bias so dramatically on these, but we'll see. Okay, let me show you something interesting here. Okay, I got the old Mullards out, and I got the Svetlana in there, and I haven't made any adjustments yet. But watch this. When I plug this one in and I check the cathode current on that one, actually, it's 55, that's not bad at all. We could tweak that one right in, but look at this one. Bing! So that goes to show that even when you change tubes within its own, you gotta. I'm sorry, I can't tell you exactly what the voltage is. That would just take a whole lot more. I'm sorry, you know, target there. Exactly what the voltage is and how much it's changing and all that kind of stuff. That'd take a whole lot more effort flipping this thing over and everything. But there it is, just a little over 50. And that one's a little high, so let's run that one back. Now that's what I'm doing each time. But you can see just changing even the same tube. It rounded up pretty darn high there, didn't it? There we go. That's close enough. But we have our that's like 50. Oh my goodness, 55. That's 52 milliamps. We'll settle with that, so we don't drag this thing out for eons here. Okay, let's see what we got here now. Okay, run this down to about 0.1. That's a little over. There you go, 145. 45. Round it off, you know. 45.2, 45. It's 45 and 1%. The new ones, the ones that won were the old vintage ones. Isn't that amazing? From 1959, I believe that's the year they were made. 60 years old, and they're still doing. They still outperform. Now that doesn't mean, you know, I do this as unbiased, and no pun intended, as I can. And you know, the difference between buying the some standard Svetlana electro harmonics, whatever your choice is, Mullard, etc., over paying a ransom for well, I've already put them back in the box for these. They're in a Svetlana box, but this is the old vintage Mullards. Yeah, they actually do perform a little bit better. And there's our meter saying it's about 47 watts. That's a little off a little bit, in 42, 46. Well, anyway, so it is. There you go. So I enjoyed doing this. I have done these types of measurements a number of times over the years, but it's always interesting how they turn out. And they tend to turn out pretty much the same. The difference is being always quite small, you know, as long as everything is in good order. Well, let me show you another project I'm going to crank up here pretty soon. You'll probably like. This is one nice output transformer. Look at this guy. This is a Triad S152A. It says 7 hertz to 50 kilohertz. 7 to 50,000 CPS, cycles per second. Power level 65 watts. It's got a 4,000 ohm primary. It's got the ultralinear taps 4, 8, and 16. What I thought about doing was just removing the old output transformer from a Mark III and putting this one in it, but it's not going to fit. This one's just a little bit too big. It's not grossly bigger, but it is bigger. So I guess I'm going to have to build a whole entire amplifier to test this transformer. That's what I do. And I guess I'm going to run, well, at 4,000 ohms, I figure I'm going to run 6550s, KT88s into it. Although I'd like to run something a little more exotic. But the triode tubes are really a kind of a poor choice for these plate loads. I mean, if you're running 300 Bs, that's fine, but you know, I don't want to run 300 Bs into something rated 65 watts. I want to push this thing to the limit. I want to measure it at 100 watts. So, but I'm tired of building with 6L6s, EL34s, KT88s, etc. You know, so I don't know what I'm going to use. I'd like to have some low voltage type triodes. But most of the triodes, even the SVT 10s and whatever I have, you know, they all want at least 1,000 volts. And when you start running the voltage up high, the current starts dropping. Only makes sense, and then the impedance starts rising. So this is not a good candidate for a 1,500 volt tube unless, you know, the current's really high, and that's just the way they go. So, you know, if you want to stay into the realm of conventional tubes, you gotta deal with these beam power tubes and pentodes, stuff like that. So I'm not quite sure what I want to drive this with, but it is a beautiful transformer, and I just have a feeling it's going to perform really nice. Well, anyway, that is what I've come up with tonight, measuring these vintage and new tubes. And I have to say the EL34 is that's what I've been running in this thing for many years, and I'm always pleased with it. Thanks for watching. Stay safe.